Potatoes don't just make great fries. Believe it or not, you don't need any batteries or a source of electricity to power a clock. You can just simply use a potato. My hypothesis is that the juices in the potatoes contain chemicals which facilitate electricity generating chemical reactions with the help of electrodes. You will need 2 potatoes, 2 galvanized nails, 2 copper wires, 3 jumper wires with alligator clips, and a simple battery-operated LCD clock. Okay, so to start off, we have already labeled these potatoes 1 and 2. So the next thing is to insert the galvanized nail into each of the potatoes. To each of the potatoes. And then you will insert the copper wire into the other end of the potato. Okay. So now we will have to remove the batteries from the clock and make note of the positive and negative terminals, which are located here on the inside. You won't be able to see it, but we can see where the positive and the negative side is. Positive, negative. So we're going to take one of the wires with the alligator clips and connect one end of the to the copper nail on potato 1. And copper nail, copper. And the other end will be onto the positive terminal of the clock. Yeah, that's fine. So the positive. Let's do that. Okay. So there's that. Now take the other wire and connect it with the galvanized nail on potato 2. Oh. And use the other end and connect it to the negative terminal of the clock. So we'll do that. The negative side. Okay, so now that they're connected, the third alligator clip wire will connect the galvanized nail in potato 1 to the copper nail in potato 2. This will complete the circuit. Hopefully this works. Takes a little while for it to turn on, but maybe. So you let me know when it's on. Try to do this part. Let me hold that there. Here, let me hold it. Tell me if it's working. It's a potato, it's not gonna work so fast. Let's see how that goes. Anything going on? You make sure everything's right. These things are supposed to be like this. Wait, before you touch it. No. Here, good too. Thank you. Turn down. Takes a little while. on them. Call an assistant. We're still waiting. This is twisted.
Assistant number 3.
Number 2. Okay, let's see. Expert. Right? I thought I did it correctly. Technical difficulties. You can do it. Oh, it's coming on, it's coming on. Oh, no, put it back on. Can you see it? Oh, at least you can see the numbers. Yay. No, but you saw it. It happened. It happened. Did you get it? Yes. All right, come sit over here, buddy. Thank you. He's the expert. Okay. So it did turn on like you saw, so it works. How cool was that? That was really cool, huh? So, each potato basically functions like a galvanic cell, which releases energy in the form of electricity as a result of chemical reactions. The potato as a whole becomes the cell casing. Its juice works as a conductor, allowing the flow of charged electrons, and the phosphoric acid naturally presented in the potatoes provides the hydrogen ions for the chemical reaction. A potato battery is an electrochemical battery, otherwise known as electrochemical cell. An electrochemical cell is a cell in which chemical energy is converted to electric energy by a spontaneous electron transfer. In this case of the potato, the zinc in the nail reacts with the copper wire. Well, that was our experiment. It worked well. It worked for like 2 seconds, right? So, it works. I bet you can keep it on for longer, but we just didn't know how to. But thank you for watching, and that was the potato battery.